Sorry, my computer's a bit slow. I was running Zoom earlier, or MATLAB, I mean. Okay. All right, can everyone see this?
Yes.
All right, so I finished it. This is my presentation. It's about like the three most well-known text-image AI systems. Um, so they're DALL-E, Stable Diffusion, and Midjourney. So I went over this last time, but I think I understand the concept a bit more this week. So basically, yeah. So DALL-E is used. It's currently in its second version called the DALL-E 2. It's created by OpenAI. It's mainly text to image, and they made a deal I think with Shutterstock for some of their images. And then Stable Diffusion is created by a few different companies. It's it You can use it for text to image, but you can also use it to modify images or what they call image to image. And it's actually I'll explain later what this is, but it actually uses a lot less space than the others, and so it can actually be run on a computer without any access to the internet. You have to download a trained version of it. And then there's Midjourney, which is created by David Holtz. You can only access it through Discord. It's text to image. There's a lot less that's known about that one, so I'll talk about that one last. So DALL-E, so you can see this is an image created by DALL-E of a teddy bear riding a skateboard. So this is AI generated. It looks extremely realistic. Um, so what basically happens? Okay, so yeah, so basically these language models don't actually understand. You don't input words to them. The word is going to be encoded into what they call a word vector, which is is a vector of a bunch of different numbers. It's supposed to represent a word in I think I forget exactly what it's called, like text space or something like that. I'm not entirely sure what the name is for that. Do you remember Trent reading about that with the Transformers? Do you remember what that was called?
Uh, Actually, let me look it up.
When they like encode a word vector? Oh yeah, it's called a word vector. Is it
Word
like an
vector. Yeah. Yeah, something like that. Let's go, I think, positional encoding.
okay? And then after that happens, what basically happens is that you then have an image encoding, and the goal is to translate the text encoding into the image encoding, and then you use that information to create an image or modify it. And this is done in the decoder, and by a process called noise reduction. So I'll explain what all these mean. So what happens is DALL-E uses another AI program called Clip. What Clip does is it will take captioned images and it will create from those captioned images, it will then create a space for the text and a space for the images. Um, and yeah, so this has been trained on millions of images and their captions. Uh, it's DALL-E relies on Clip to decipher the meaning of the caption in the image. So basically, you have to know these two spaces, and then you have what Clip does is it makes sure that they both sort of match with each other. So you have space for words, and you have the space for images. Then DALL-E uses something called a prior. This is uses something called a diffusion model. Um, hold on. Okay, this is something I'm not entirely super clear about. Whatever. Okay, long story short, DALL-E uses a transformer to learn the relationship between the clip images and the clip text encodings. And so what happens is if you can input a word and it will give you image information through this transformer.
Oh, wait, that actually makes sense because the transformer is originally used for language translating, right?
Yeah, you translate from one language to another language, but this
Hmm.
can translate text to I think what they're called are like image tokens. Whatever it
Yeah,
is,
exactly.
it's information used to modify the image.
I see. Yeah, that makes sense now. Yeah, it's basically you convert them to a language, two different language, right? Image language and text language, and then
Yeah,
the transformer
that's
you can,
exactly.
I see. Yeah, that makes sense. Yeah.
So what I'm a bit confused on still is that it seems like Clip understands the relationships between the image space and the text space, but Clip isn't the thing that translates between the two. What I think It's hard because there's a lot that I still don't know about this. What I think is going on is that the transformer uses the relationship clip finds to train itself, but is ultimately more versatile than clip. That's I think the way that's at least the way I understand this. Um, so yeah, and then so with this, so then this transformer is used in the next part, which is uses a model called glide. This is a process called reverse diffusion. So what diffusion is that you're taking an image and you're adding white noise to it to eventually make it completely meaningless and all the information has been drowned out. So instead of drowning out the information, reverse diffusion does is it finds ways of giving white noise information to turn it into an image. And so it uses the image, the information given by the transformer, which it got from the text encoding, which it got from the input, to create an image. So yeah. Next, so stable diffusion is very similar to DAL-E, except what it does is what DAL-E does is it does this in pixel space, which what pixel space means is it means that each wait the hold on, I'm trying to figure out how to word this. The brightness for each pixel in each color is its own dimension. You can imagine how many dimensions this a simple picture like this would have. This causes a lot of time and training, and it also takes up a lot of space. So instead, what Stable Diffusion does is it does this within the latent space of an autoencoder. So instead of creating an image or doing this process that DAL-E does in pixel space, it will either create an image in the latent space and then decode it, or it will encode it, your input image, work on it in the latent space using reverse diffusion, and then decode it back into your modified image. This is the reason actually why you can run it on a computer without internet connection, because it actually takes up a lot less space than DALL-E. But it's very similar in many ways. So you can see on this schematic right here. So it's basically an autoencoder. It's basically extremely souped up autoencoder that does a lot more stuff inside the latent space than a regular autoencoder. And so yeah, so what DALL-E does is what Stable Diffusion does is okay, hold on. I need to read my slides before I present. Sorry about this. Okay, so if we take the example of an image, you you encode the image into the latent space, then you add noise to it, and then you add a small amount of noise, and then what you're basically doing is you are using reverse diffusion to turn that noise back into a modified image. So as you can see right here at the bottom picture, you have the noised image. It can be completely noised. If it's completely noised, and it's basically just a text image, because you could just start. You know how like GAN models, well, they just start with like a random vector, a random, and then they basically create an image out of that. It's
Yeah,
basically
exactly.
what's going
Yeah.
on with text to image. But with image to image, you kind of noise out the image to an extent, and you encode it, work on it using reverse diffusion in light space, and then decode it as your modified image. And so all the inputs from the translator will work on the reverse diffusion within latent space. It uses something called a noise predictor. This I'll explain this a bit later, but it doesn't denoise it all in one step. Usually, it will take a little bit of noise off and then estimate what a completely denoised image looks like, and then we'll keep going this in multiple steps. And then the transformer, the inputs in the transformer will change what the noise predictor believes in such a way that the modified image will then take your text commands into account. So I'll unpack this a bit more. So as I said earlier, it basically it uses an autoencoder to encode the image before it works on it. And then uses reverse diffusion to work on the image. So basically what happens is that you have an image. It could be complete noise or it could be partial noise. And the UNet predicts how much noise is present. And then it will try to create an image by subtracting that noised image, subtracting the predicted noise from the noised image. what the translator does is it will then give the UNet image information so that it skews its estimation of how much noise is there. And so that means that the image that comes out at the other end is not just a denoised version of the original image, but it is now a modified version of that image. Because it was denoised in a way that took basically the information that you gave the text command. So, like I said earlier, both DALL-E and Stable Diffusion use a transformer to turn the text inputs into an image input. Um, Stable Diffusion also uses Clip to do this to have both the word space and the image space. And so, like a transformer, it doesn't do this all in one go. Like as you can see at the very beginning, it's not as if it gives the image input at one spot. It kind of breaks it up, in a similar way to how like a transformer, when you're translating from like maybe English to German, the output is the next word. It isn't the full sentence, and then you feed that back in along with the English sentence to give yourself the next word. It kind of does the same thing with this transformer. So you input basically your sentence description, and it has a bunch of tokens for image information, and these are inputted into the reverse diffusion model at different steps, as you can see right here. So yeah, like as I said earlier, so now what this does is it skews the UNet's estimate of how much noise is present, so that the denoised image now represents uh, your desired image, which is now a modified version. And so once this process is complete, which is done in latent space, the image is then decoded back into pixel space, and you have your completed product. So all these images right here are done with Stable Diffusion, and they look extremely realistic. So yeah, apparently you could, by drawing this little stick figure, and if it's trained on enough images, it can generate basically a live action image from that. All right, any questions before I move on to Midjourney? I know I was kind of a little all over the place.
Yeah, it's fine. I'll ask you a final question at the end because actually in one of my class I have like an assignment and I need to use this, so I will ask you at the end about that.
Okay. All right, let me just go back and explain something I think I glossed over, which I forgot what it was. Yeah. Okay, yeah, I'll think of it on. Okay, so Midjourney, it's text to image, like DALL-E. What it does, what sets it apart from the others, is that when you uh, when you ask for an image, it will then give you a grid with four different image styles, and you choose which one you prefer, or I think on a scale which one you prefer. And then it will then give you a higher resolution version of that. There's also other ways you can tweak the style a bit more. Um, it's weird. You can only get it through Discord, and then unlike DALL-E or Stable Diffusion, which offer free versions that aren't as high quality, this only gives you 25 free images, and then you have to then after that pay. Because the owner who created it intends to use this for profit. It's unlike DALL-E or Stable Diffusion, which are called open source. This is closed source. So there actually is very little we know about it. We know that it uses probably a reverse diffusion model similar to DALL-E and Stable Diffusion, but other than that, it's basically a trade secret how it works. So yeah, that's basically what I was just saying. That's another image that was created by Midjourney. So yeah, that's it.
Yeah. Yeah, back to my assignment. It's so the class is about zombies and I'm supposed to do
Wait, it's
something
about
with
what?
zombies.
Zombies?
Yeah, it's a writing class.
Oh, okay.
Yeah, so I'm supposed to do something about zombies and
I
I'm
was I
I'm
was worried. I was worried you're like in
yeah.
some crazy like biomedical engineering.
No, no. Yeah.
Never mind.
Yeah, so let's see. I plan to do like comic books and the manga and stuff like that.
Yeah.
Yeah, I'm planning to do like something like that. Colorful and with AI, but I'm not like I don't know anything about it yet. So like which
Mhm.
website do you recommend or which model should I use?
I think for that DALL-E too.
Mm,
Because Stable Diffusion is more for image modification. You can generate images with it, but yeah, I've actually seen some people generate quite a lot of stuff from DALL-E too, just with like small prompts. Um, yeah, I mean, I'm probably not the best person to ask about this because it literally just spent a few hours of the past 3 weeks looking this over and then forgot a lot. That's why my presentation was such a mess. Um,
okay,
so so yeah, but my gut feeling is probably DALL-E too.
totally. Do you have like a link to it or something? Because I
No,
really don't know. Okay,
no, this is just I haven't played with it yet, actually. Um, but this is just stuff that I know about it. I think it should be
okay,
pretty easy to find though.
okay. Yeah,
I think
because
it's
yeah.
free, and if you want really high definition images, you have to pay like a few cents or something per image.
Let's see. Like the hard thing about manga is that the main character has to stay the same. Like you can't you can't change the main character every image, right?
Okay, Stable Diffusion might be your best bet then, because I think what you can actually do is you can like so it's trained on a bunch of words that mean certain things. I think you can actually define your own words. And
Mm,
so you might be able
okay,
to create a character, define your character as is, and then use that character later.
I
I'm
see.
not entirely sure that's true, but it seems like some of the stuff I read on Stable Diffusion seems like you can do that.
I see. Okay, yeah. Thank you. Stable diffusion. Okay.
You're probably gonna have to look into it yourself because this is just extremely high, just basic overview of what the systems are. That's like a
Okay.
very specific demand.
Yeah.
I'm not entirely sure which one would be best. Wait,
Because
so mangas, that's a form of anime, right?
yeah, that's a form of anime, but in written form instead of like video.
Okay.
Yeah. And like I want to look it up online. Like the first few tools they are like you have to pay or you learn free a little bit. So I was thinking if you know some actual free one,
Actual free what?
like free model to use, but I mean
Okay.
you don't know either, right? So,
Well, I think both Dolly and Stable Diffusion have free versions.
yeah, I know, but like when I look up online, like a few first selection, a few first website, they are paid version. So
They probably do that on purpose.
yeah, the only way to do that. So I have to find like the correct free version one.
Yeah, I'm actually thinking of looking into them just for my own artistic use. If I think I'll probably do that this weekend. If I find anything, I'll send it to you.
Yeah, sure, yeah, thank you. Right.